$179 a month, that's a car payment. That's dinner out twice a week. And according to the math, that's all it takes to retire a millionaire. But here's the thing, the vast majority of Americans will never get there. So the question is simple. How much money do you need to set aside every single month to end up with $1 million? But the answer depends on three critical variables when you start, what return you earn, and whether inflation eats your finish line before you cross it. We built a full model across multiple time horizons, multiple return assumptions, and adjusted everything for inflation. Because here's something most of these calculators won't tell you. $1 million today is not $1 million when you retire. We're going to walk through every scenario, show you exactly where the tipping points are, and give you a framework to figure out your real number. One more thing worth noting up front, there are currently about 24 million millionaires in the United States. That's roughly 1 in 11 American adults. And the country is minting about 1,000 new ones every single day. So this isn't some fantasy, it's a math problem, let's solve it. Alright, let's start with the baseline table. We calculated the monthly savings required to reach $1 million across 4 time horizons, 40 years, 30 years, 20 years, and 10 years. At 2 different average annual returns, 6% and 10%. 6% represents a conservative, inflation-adjusted stock market return. 10% is the nominal historical average of the S&P 500 before adjusting for inflation. At a 10% nominal return over 40 years, you need just $179 per month. Over 30 years, that jumps to $481. Over 20 years, you're looking at $1,382 a month, and if you only have 10 years, nearly $5,000 every single month. Now at the more conservative 6% real return, the numbers shift. 40 years requires $522 a month, 30 years just over $1,000, 20 years about $2,200, and 10 years over $6,000 per month. Look at the shape of this curve. The difference between starting with 40 years and starting with 30 years is not linear. You don't need a little more money, you need 2 to 3 times more. That's compound interest working in reverse against you. Let's zoom in on that $179 per month scenario, because it's the one that gets people excited, and it deserves a reality check. At $179 a month for 40 years, your total out-of-pocket contributions come to about $86,000. $86,000. The other $914,000, over 91% of your final balance, comes purely from compound growth. You put in less than a tenth. The market does the rest. That is the single most important chart in this entire video, but here's the catch, that 10% return is nominal. It doesn't account for inflation. In real purchasing power terms, your $1 million 40 years from now buys significantly less than $1 million today. We'll come back to that. For now, just understand that $179 a month is mathematically valid. But it requires 2 things most people don't have: a 40-year runway and the discipline to never stop. Now here's where compound interest gets really visual. We tracked how long it takes to hit each $100,000 milestone. Assuming a 10% average annual return and consistent monthly contributions. The first $100,000, that takes roughly 8 years. You're grinding, it feels slow. Your contributions are doing most of the heavy lifting, and the growth feels almost invisible. But watch what happens next. The second 100,000 takes about 5.5 years, the third around 4 years. By the time you're going from $700K to $800K, it happens in under 2 years. And the last stretch, $900K to $1 million, takes roughly 14 months. This is the snowball effect, and it's not a metaphor. It's literally how exponential growth works. Each 100,000 comes faster than the last because your base is bigger. Your money is earning money on money on money. This is why the first 100,000 is widely considered the hardest milestone in wealth building. Once you clear it, the math starts working with you instead of against you. But here's where it gets interesting. Most people quit before they get there. The median savings for Americans under 35 is just $5,400. At that rate, 100,000 feels impossibly far away. And that's the tragedy of compound interest. It's most powerful for those who start earliest. But starting is exactly what most people struggle with. Let's quantify the cost of procrastination, because this is the number that should keep you up at night. We compared two people. Person A starts investing at age 25. Person B starts at age 26, 1 year difference. Same monthly contribution, same return, same retirement age of 65. That single year of delay costs approximately $115,000 in final portfolio value. Let me say that again. Waiting 1 year, 12 months, costs you over $100,000 at the finish line. And it compounds from there. Start at 30 instead of 25. You either end up with significantly less, or you need to save dramatically more each month to catch up. At a 10% return, starting at 25 means you need $179 a month to hit $1 million by 65. Start at 30, and that number jumps to $263. Start at 35, $481. Start at 40, $754. Every 5 years you wait roughly doubles the monthly requirement. This is not a guilt trip, it's just math. And the math says that time in the market is not just the most important factor, it's more important than almost everything else combined. Now let's address the elephant in the room that most millionaire calculators completely ignore: inflation. $1 million is the goal everyone fixates on, but $1 million in 2066 is not $1 million in 2026. Using the historical average inflation rate of about 3%. $1 million 40 years from now has the purchasing power of roughly $307,000 in today's money. And if we look backward, $1 million today only buys what about $407,000 bought in 1990. So when we say you need $1 million to retire, we need to ask, do you mean a nominal million or a real million? Because if you want $1 million in today's purchasing power when you retire in 40 years, you actually need to target about 3.26 million nominal dollars. And that changes the math completely. Instead of $179 a month at 10% over 40 years, you now need closer to $580 a month, still very doable. But it's a fundamentally different number than the one most people cite. This is why we prefer to run our calculations at the 6% real return rate. It already accounts for inflation, so your target stays at $1 million in today's dollars. At that rate, you need $522 a month over 40 years. That's the honest number. So the math says $522 a month, inflation adjusted, over 40 years gets you to a real million. That's about $17 a day. Sounds manageable, right? But let's look at where Americans actually stand. The median retirement savings for households under 35 is approximately $5,400. For households 35 to 44, it's around $60,000. 59% of Americans say they can't cover an unexpected $1,000 expense. The personal savings rate has been hovering around 3 to 5% of income in recent years. And roughly 56% of Americans say they are behind on retirement savings. There is a massive gap between what compound interest requires and what people are actually doing. And it's not just about discipline or lattes. Median household income is around $75,000. After taxes, housing, healthcare, food, transportation. The idea that everyone can carve out $500 a month assumes a level of financial margin that many households simply don't have. This is the tension at the heart of the millionaire math. The formula is simple, the execution is not. All right, let's bring this all together into a decision framework you can actually use. First, figure out your time horizon. How many years until you need this money? That single variable matters more than almost anything else. If you have 35 to 40 years, you're in your 20s, you need roughly $175 to $525 per month, depending on your return assumptions. Even at the conservative end, this is achievable for many working professionals. The priority is just to start, automate it, don't touch it. If you have 25 to 30 years, you're in your early to mid-30s, you need about $480 to $1,020 per month. This is where employer matching becomes critical. If your employer matches even 3 to 5%, that can cover a significant portion of your required savings. Maximize that match before doing anything else. If you have 15 to 20 years, you're in your 40s, you need $1,380 to $2,200 per month. At this stage, you likely need to combine aggressive savings with income growth. Consider maxing out both a 401k and an IRA or Roth IRA. And if you have 10 years or less, the monthly numbers become very steep, $5,000 to $6,000 a month. At this point, the strategy shifts. You may need to adjust your target number, plan to work a few extra years, or explore additional income streams. Second takeaway, use the 6% real return number, not 10% nominal. It's more honest and it already accounts for inflation. When someone tells you that you only need $179 a month, they're technically right. But they're quoting a number in future dollars that won't buy what you think it will. Third, remember the snowball. The first 100,000 is the hardest. If you're in that grind right now, the math says keep going. It accelerates. Every dollar you invest today is worth dramatically more than a dollar invested 10 years from now. And fourth, if you can't hit these numbers right now, start with what you can. Even $50 a month at 25 puts you at roughly $350,000 by 65 at a 10% return. That's not $1 million, but it's $350,000 you wouldn't have otherwise. The best savings rate is the one you actually maintain. If you want to see how we modeled the best account types for building this kind of wealth, Roth IRA versus traditional 401k versus taxable brokerage, we broke down the full tax math in this video right here. We'll see you there.